I'm glad to contribute to the CAS Day. Our Reggiani is also from my department, Economics. Giacomo Galiazzo is a former student of Aura, who's an expert in coding. So he's our programmer in what I will show you. This presentation is actually maybe more of a showcase of a software than a presentation on tourism. So tourism data are used in this presentation to showcase the software. So it could have been other data, it could have been migration, it could have been commuting, it could have been trade, more or less, it would have been the same presentation. But I had some previous research on this data, so I can show you a little bit more on this. So, well, the title kind of partially solved the content of the presentation. What we do here is we propose an easy-to-use algorithm that we can use to calibrate and estimate this strange thing that is called the doubly constrained spatial interaction model. This type of model which if I was in a regional science conference, I would spend more or less 0 minutes presenting because it would be common knowledge. But here maybe I'll try to say something. The added value here is that we have the software to calibrate a model that is pretty difficult to set up normally for the average researcher. And our tool is very simple to use, and especially with regard to the fact that we estimate that this so-called doubly constrained version of the model. The example I use is this tourism flows between 20 Italian regions. Trentino to Algeri is all kept together, although in the official data they are separate. So basically I have for each year of data from 2017 a full squared matrix of how many people go from Emilia-Romagna to Lombardy, how many people go from Lombardy to Apulia, how many people from Puglia to Sardinia, etc., including internal traveling, which is the diagonal of the so-called origin-destination matrix. So it's 400 observations per year times 17, 18 years of observations. And what we wonder here about the data, after I show how the algorithm works, well, I'll try to do something with the data and try to look if accessibility changes with economic crisis, if distance deterrence in the spatial interaction model changes over time, and to what we can try to correlate accessibility, which is what we measure. So in a spatial interaction model, or you might know it as a gravity model, in regional science we are kind of stopping to use the terminology gravity model because the similarity with the Newton's gravitational law is very old, and we have plenty of theoretical explanations for the spatial interaction model, and we don't need to refer to gravity, which is a very old similarity. In the spatial interaction model, you basically model the flow of something, people, information, goods, whatever, from region I to region J on the basis of some characteristics of region I. The characteristics, whatever they are, could be also the same variables of region J, the destination region, plus some variables that define how complex or how easy or how difficult it is, the interaction between these two pairs of regions. Basically, the basic variable that's used is some proxy for cost, interaction costs, such as distance, travel cost, travel time, which is used as a deterrence. There are two ways to estimate the spatial interaction model. The simplest way is to estimate this model. It's a multiplicative model, like a production function with the exponents, which if you estimate it in log becomes linear. This is the easy way. It's very easy to estimate. There's no calibration needed. You just estimate with OLS if you want, or with a Poisson regression, which is more suitable. The weakness of this model is that because you have this squared origin-destination matrix, you basically have double entry bookkeeping, double entry tables, in which you have to respect the marginal sums of the matrix. So the sum in J of the flows of region I, from region I, have to sum up with total number of people living in region I. The sum of flows in I of Tij have to sum up to the total number of opportunities in region J. For example, if it's commuting, if it's residents of every region, resident workers, and number of jobs in every region. With tourism, it's number of people who travel out of every region and number of arrivals of every region. Okay? So depending on the context, they change slightly. The problem with this unconstrained version is that if you estimate it with OLS, Poisson, you don't respect these conditions. These are 2 times n constraints, which are called the additivity condition. And this is not good for comparative statics, for general equilibrium effects, because I give you the simplest example. I just made it yesterday in class. If the number of people residing in region 1 increases by 2, increase by 100%, they multiply by 2. And of course, also the rivals somewhere increase by the same amount. When you have it in the multiplicative model, 2 times 2 becomes 4, and you have 4 times the amount of additional flows, but the number of people in the system are 2 that you added. And that's why you need to use something that takes into account these constraints. Then, of course, the distance function could be anything: quadratic, exponential, power, you name it. Many functional forms have been tried in the past. So, because you cannot use the unconstrained model for comparative statics and prediction, in the 70s and the 60s, Sir Alan Wilson developed what is called the doubly constrained spatial interaction model, which is the same model, but you can see, I have my pointer. Ooh, I bumped the microphone. You have more or less the same equation as before, but with these terms AI and BJ, which are additional terms in the regression, and these are highly nonlinear constraints. You can see the complication because in every AI you have all the BJs. In every BJ you have all the AIs in the denominator. So they are. This is the complication. It's difficult to calibrate this model. You cannot use OLS to do this, and you need an iterative algorithm to calibrate it. The good thing is that it relieves the problem of the additivity condition, and of course the problem is that you have these nonlinear constraints. When you have estimated this, say, correct way of working with the spatial interaction model, you can say, I'm going to, this is because of the transformation to PDF. You lost the end of the equation. You can calculate an accessibility score for every region. Accessibility is defined in many ways in the literature. Let's just say there's potential for reaching opportunities. And accessibility of region I is computed as the sum in J of the DJs times the distance deterrence function, which you cannot read right now. So the advantage of using the software is that you can compute correct, proper accessibility scores to evaluate how accessible every region is. So there is an algorithm coded by our friend Giacomo. It's called the spin model. Now it works as a website. And it's an iterative optimization algorithm, which I'm not going to spend time to explain because I don't have enough. But it starts with two simple databases: the flows, the origin destination matrix for every year, and the distances. I'm sorry for the symbology that he used is different because T here is travel time and not the flow. The flows are C, but only for the algorithm slides. And so you start with some, I have more, no, I'm not using this, right. You have this iterative algorithm which starts with some simple initial values for the A and B's, the balancing factors, the constraints, and then through optimization it goes into defining through iterative modification of the parameters, goes through estimation and gives you your doubly constrained spatial interaction model with calibrated parameters. I wanted to show, let's see if it works. I wanted to show an example from the website. Let's see if very quickly we can do it. Is this the correct password? No. I tried to go with memory, but my memory is not good enough. Let's see. Okay, so I have already some data loaded on the website. So I'll just use maybe one of the different one of the different data sets because I have to, right now we have to load every year of data, every cross-section separately. So I have loaded my data. I should choose to estimate the doubly constrained model. If I wanted, I could estimate the unconstrained one. I could choose exponential versus power formula for the distance or travel time deterrence, and some other parameters that I'm not going to speak about now. I just have to tell the algorithm which one is origin, which is destination in the data columns. Done. And now I'm going to calibrate beta, which is the distance deterrence parameter. And it's also, of course, going to calibrate the other parameters, which are all the AIs and all the BJs. And here we are. Beta's value in an exponential function now is minus 0.003. You have all the log of the estimates. Final equation is there with the R squared. And also here you can show the resulting accessibility. So for every region here, based on this year of data, you have an accessibility score which you can use, for example, to rank the regions in terms of their accessibility. The number in absolute terms doesn't mean much. It's the rank between regions that matters. So what we do is, let's see if I can go back here. Yes? No? Freccia che? In basso a sinistra. Okay, so I work with this tourism data. I had worked on this tourism data before with Maurizio actually and Guido Candela in previous works where we were estimating a regular Poisson-based spatial interaction model in a regression form, unconstrained, but with fixed effects, which gives you something similar. And we use this to study the relevance of UNESCO World Heritage Sites in driving tourism flows. We had set up, the equations disappeared in the conversion to PDF. Okay, that saves me some time. Last year of data, because now we spent it 2017. These were on older data. And we had many explanatory variables in addition to the number of UNESCO sites, which were the interest variable. You know, you can see from regional GDP to price indices to cultural demand per state institute, diffusion of cultural events, WHS sites, and in the end we had also you lost some of the columns. The conversion PDF was horrible. So we had 3 models where in the end this got lost too. Not my fault. But in the end, the funny thing is we had an estimate of the importance of UNESCO World Heritage Sites for the destination region and also for the origin region, which was telling you also how emissivity from a region was changing depending on your endowment. And okay, no, here there was no distance because there were region pair fixed effects. Here we had the elasticity for distance, and you see we had a nice, very nice -1 distance elasticity. Okay, so this was the old paper. Now, extended data, and what we do here, we calibrate the distance parameter with an exponential function and with a power function. I think the power function is the one with the highest fit. So we retain power, and then we also look at R squared, the accessibility scores and rankings over time, and we try to relate it to possible determinants. Good. The graphs are all gone. That's a disaster. Hey, this is the conversion again. So what we are left with is the rankings of basically the graphs were showing that the R square doesn't now have significant developments, and the distance parameter, the entity of the parameter, was basically growing in the first years, which was interesting already. So in the 90s, the deterrence of distance was growing bigger, slightly bigger, and then at the time of the economic crisis, which you cannot see, the growth of this distance parameter was stopping. So my guess was maybe during the crisis, the deterrence of distance had grown greater, right? Because of scarce availability of disposable income, you become more sensitive to distance because it implies higher costs. No, the distance parameter stopped growing with the economic crisis and remained stable. So counterintuitive result. Anyway, you cannot see it. So, for every year, 18 years of data, I do a ranking, I compute the accessibility scores and I do a ranking. This is a zoom of just 4 years together. And I color code them just for me to recognize how the regions move in the relative rankings every year. So basically what you can see from the larger picture is that Emilia-Romagna is first from the first year to the last year. And then also, what is the yellow? Veneto is first from the first year to the last year. And the gray ones here, which are all southern Italian regions, pretty much remain in the same position. Sicily, I think, is always last. So it's a rather stable ranking. That's why we want to now change it to international tourism flows to see if we have more dynamics going on. So you can just give the rank to every region for every year, and look at how the rankings correlate over time. So this was just a simple Spearman's rank correlation, and you can see that over time the correlation, obviously, with the first year ranking goes down slightly, but not so fast because they're very similar. So in the end, the last question we had, and more or less this is where we are with the analysis and where we are still thinking of what to do, is what can we do with these rankings? Because they are descriptive, right? They just tell us, okay, Emilia-Romagna is the most accessible, Veneto is the second most accessible, some regions have very scarce accessibility and in a stable way. What can we say about that? So what we try to do is to relate these rankings to possible determinants. So what we do is just, I take all the explanatory variables I had from the previous papers and I updated to the most recent year of data available, and I just look at correlation between the accessibility scores of that most recent year of data with the value of these variables. So what you can see here is that apparently the diffusion of shows and recreational or religious shows is the one with the strongest correlation with our accessibility scores. Satisfaction about the train system, that's the second variable, so the training, is also showing a high correlation with accessibility. Diffusion of small crime, I think, yes, because violent crime is here. Diffusion of small crime is also rather strongly correlated. Spesa RICR is public expenses in recreation and public activities as a percentage of the total spending of the region. Also has a good correlation, and you also have some small negative correlation with percentage of non-baseable costs. So more or less this is where we are, where we try to show that you can easily use this algorithm, which is now in the form of a website, to compute accessibility scores and describe the level of accessibility of regions, of a system of regions or spatial units in time, because hopefully in the future we might be able to put directly the panel data into the algorithm. Right now it's a cross-sectional algorithm year by year. What happens is well, with the regional rankings they're very stable, so we were hoping to use province level data, but ISTAT confirmed to me that they don't exist. So you have by province the number of people coming from a certain region, but you don't know how many people come from a certain province. At least this is what they told me. So because there is no OD matrix at the province level, which would be much more interesting with 100 regions, yes, 100 spatial units, probably we will move to international tourism flows where we have 200 countries in the world and with a longer time span probably. The economic crisis does not seem to have an effect. Actually, the increase in distance deterrence stopped with the economic crisis. And this is where we are right now stuck for lack of time on what to do with the accessibility rankings and how they correlate with the different variables and what to do with it. And that's why I asked Giovanni maybe to give me some ideas on this as a discussant, looking at the rational causality between the accessibility rankings and the determinants. And of course we're wondering if it makes sense to analyze the rankings directly via regression modeling. There must be a method for analyzing variables which are ordinal and not numeral. So I'll look into this stuff in the future. Thanks for listening.
Well, first of all, thanks for having me as a discussant for this paper. Well, I'm not an expert of this kind of literature, so what I've prepared for today is not a proper discussion, but I'm presenting a couple of ideas that came up to my mind when I read Roberto's presentation in order to answer to Roberto's questions. So the main questions that Roberto has at the end of his presentations is basically how to evaluate the double causalities between accessibility measures, or how to evaluate double causalities between accessibility measures and macroeconomic variables. So in order to test this double causality, that's are my two answers. So first of all, a non-recursive Satura VAR, and second, a tensor model. So what a non-recursive Satura VAR, I mean something like that. So what we want to try to evaluate is, let's say, assume that we have an endogenous vector. So the endogenous vector is composed by accessibility measure of country I. So for the moment we are estimating a country-specific Satura VAR. So we have the accessibility measure of the country I. The other measures that Roberto has are efficiency for country I, training infrastructure of country I, or cultural entertainment of country I, and some other measures. So what we want to try to evaluate is basically the relationships between these variables, and in order to do that, we want to try to estimate these metrics capital B as full as possible. So in order to take into account all possible causalities between all of these endogenous variables, we want to try to estimate these metrics completely full. In order to do that, we cannot estimate this VAR using a standard Cholesky decomposition, but in order to do that, we need to find some way in order to have these metrics completely full. Well, the main drawback of this is that we don't have the spatial dimension, but I'll go there to the model with spatial dimension in a couple of slides. So here I've reported a couple of approaches in order to have a non-recursive matrix B. So in order to study the double causalities between the endogenous variables we have in the system, so the first point is non-Gaussian distribution. This is a reference I have in mind. The second one is size restrictions. So with this approach, we are not able exactly to estimate all the relationships, but with this method, we are able to estimate a set identified model. So we don't have point identification, but we have set identification. So maybe it's not the best way in order to do that. Another point is heteroscedasticity, which is a good point here, which is a good method here, but probably the number of the observations we have is not enough. The point number 4, which is proxies var, and this identification method is probably the mainstream at the moment in the literature in order to identify a non-recursive Satura VAR. And this is just an example of a reference, but if you want, I can give you a lot of that. And the idea of a proxies var is to find an external instrument in order to identify a shock of interest. So we need an external instrument which is correlated to the shock of interest and which is uncorrelated with the other shocks in the model. And if you find something like that, if you find a variable with this characteristic, we can estimate a non-recursive on impact matrix B. The last point, the last method is a combination of this, one of two or more of these methods. In this paper, they use the proxies var and size restriction in order to identify a completely full B matrix. So another interesting thing maybe is, let's say, in the same way we can evaluate double causalities between accessibility ranking of different reasons. So maybe, if I understood correctly, so maybe the accessibility measure of country I affects the accessibility ranking of country J. So maybe we can evaluate which are the double causalities between accessibility ranking of different regions. The main drawback here, we have just 20 observations, right? 20 years. We have just 20 here, so maybe the sample size is too small if you wanna this endogenous vector with all the regions. So we have 20 regions, we have 20 years, so maybe we cannot estimate something like that. But the idea is the same. We want to estimate these metrics as full as possible in order to evaluate if a shock on the accessibility measure of Emilia-Romagna affects the accessibility measure of Veneto and so on. The last point, which is maybe the best one in your setup, is a tensor model. So a tensor model is So a panel structural vector autoregressive model is a particular case of a tensor model. So here, well, you cannot see the Z here, but here we don't have a vector of endogenous variables, but we have a matrix. So in your setup, you can model directly the measure of number of arrivals. So here you have the number of arrivals from region high to region high. Here you have from region high to region 2, and so on. So you can model directly this matrix here, and not just a vector. In this paper, written by Monica and a couple of co-authors, they propose a very useful Bayesian estimation for this kind of models. And why this approach is, let's say, this estimation method is useful in your setup, because it allows to take into account sparsity. It allows to take into account, to reduce the dimension of the parameter space, because of course you have a lot of parameters in a model like that. But in the same time, you can choose flexible multivariate prior distributions for all of these parameters. So you can try to restrict the parameter you want to restrict. You can try to do more or less whatever you need, and you can test double causality. So again, if I understood correctly what you did, at the first stage you estimate the accessibility measure. Then at the second stage you want to try to relate the accessibility measure with other macroeconomic variables. With this kind of model, you can do that just in one step. Thanks. That's what I